everyone, what's up? Welcome back to Subnet Zero. So in the previous video, we had learned that computers convert data into binary number and those binary numbers convert to physical signals. But the signals still need a way to travel from one device to another, right? So here are three ways through which data is transmitted. One is copper, then there's fiber, and there's wireless. All these three you can see on this board. Now let's understand each one of them in a little bit of depth. So without further ado, let's jump right in. Let me clean up this board. First, let's do copper cables, okay? So essentially, we have different versions of copper cable, but the common ones that we see is Cat5e, Cat6, and Cat6a, okay? Cat5e used to be the older version, then came Cat6, and Cat6a is the newer version. Make sense? Let me show you first what a copper cable looks like so that you have a better idea. This is what a copper cable looks like. You see these copper wires, poking out from both the endpoints over here. So this is a cross section of what a copper cable looks like. Okay. Now, for all these three types of copper cables, a cable alone is not enough to ensure both the devices are connected. We also need a connector. Now, what is a connector basically? All of you use a mobile phone, right? And you all need to charge it. So the first question all of you will ask is it USB type or USB-C type? So essentially, let's say if you have a cable charger, okay? The endpoint where it is, this one. This decides whether it's USB-C type or USB cable. So this is what we call a connector. Keeping the same logic in mind for all the copper cables, we need a connector. So the connector is what we call RJ45. Yeah, that's the connector that we use. Let me show you what it looks like. This is an RJ45. Yeah, you see this plastic covering in the end with all these golden bars you see. This is what we call as RJ45, yeah? It's used for copper cables in most modern computers. Also, let's not forget, copper uses electrical signals, okay? Where when it comes to zeros, the voltage goes down. When it goes to ones, the voltage goes up. Make sense? So this is like a brief description of what copper cables are all about. Now let's move to fiber optics. Now let me just clear up this board. Let me just strike this through. So we're done with copper cables. Now let's go to fiber optics, okay? In fiber optics, we have single mode fiber and multi-mode fiber. Okay, so single mode fiber, the short form is SMF, and for multi-mode fiber, it is MMF. First, let me show you what a fiber optic cables look like, okay? This is what a fiber optic cable looks like, okay? You see these hair-like strands, poking out from both the ends. This is what a fiber optic cable is, okay? And these are different types of fiber optics. And now when it comes to connector, its connector is rather interesting. It is LC-SC connector. What does it look like? First, let me show you, and once you see it, it will make more sense. This is an LC-SC connectors. So an LC connector looks like the one we see on the right, and the SC connector is what you see on the left, okay? So this is what it looks like. Again, this one works on light signals, just like copper, and it comes to zeros and ones. The voltage for zeros will go down, and for ones, it will go up. Make sense? Let's move over to wireless. Let me clean up this board. In wireless, we have also variations in that as well. As you all must have guessed it, Wi-Fi 4 is the older version, then came Wi-Fi 5, and Wi-Fi 6 is the newer version. Make sense? When it comes to wireless, it uses radio waves, which looks like this. Sorry about my bad drawing, but you get the gist, okay? So now, you'll be thinking that we are done, right? Not quite. Here's where it gets interesting. Let me just go down and let's say if we have two computers, okay? Computer A and computer B, okay? And let's say if we connect them through either a fiber optic cable or a copper cable, okay? Can they communicate now? Not yet, because the cable is only carrying signals. So this is an important thing you all should understand, is that simply connecting devices together isn't enough. We also need a common set of communication rules. That is what we call the Ethernet. So what does Ethernet mean in this concept? Ethernet basically means is that the communication protocols should be set in such a way so that A and B can communicate. For example, if A speaking Japanese and B speaking English, can they communicate properly? Absolutely not. So there should be a set of understanding that both speak one language, and that particular language should be understood by both of these devices. Make sense? Now, if you want to know more about the Ethernet, the entire concept and the protocols behind it, I recommend you click the next video. Yeah? So I hope this video was fun so far. If it did, consider liking, subscribing, and sharing it with anyone who might find this useful. Please hit the bell because we only scratched the surface. There are plenty of networking videos coming up, and we are going to dive further into the rabbit hole. So I recommend you click the next video, and thanks for watching, and I'll see you in the next one. Bye.